Great. Thanks a lot today. One of the things I was thinking about as you guys were seeing all the speakers and a lot of things going on, as you go back to work next week, and someone says to you, so what did you learn? How can we take what you've learned and do something with it? My hope is that this presentation gives you some ideas. Maybe you don't use the exact same technology, but hopefully the concepts and what we're talking about here is very helpful and productive for you. So let's see if I can get this going here. So there'll be really four main areas: the evolution of AI, where it's going, the attack surface associated with that evolution, and how do we secure that attack surface? How do we control that? So one of the concepts I'm going to bring to you is AI in a box, where we're going to treat AI and zero trust. So the concept of zero trust, the AI is untrusted. And we're going to control what goes in and what comes out of it, and we'll talk about that. And then afterwards, I don't think I'll have a lot of time to have conversations, but we can definitely have conversations this evening. Love to hear any use cases you guys may have or anything of that nature. So most of you are pretty familiar with this, I would imagine, to some degree, the 5 phases of AI maturity, and then there's a future expansion. The future expansion, how I came up with that is I basically took the top 50 to 60 articles that were written globally on AI and where the AI future is. By the way, I don't mind sharing this entire presentation with you, and in the end, it has all of the references so that you know that I'm telling mostly the truth. So as we look at phase 1, that's where we were experimenting. We were doing some basic research. We were trying to figure things out. A lot of hallucinations were happening. And it was just a starter. It was experimentation. Then we go into phase 2, the RAG. And now we're starting to get some interesting information because we're feeding our own data. We're feeding our own documents. We're doing a lot of interesting things here. But it's still pretty unreliable. There was an incident with the Australian government and a large consulting firm you may have heard of. If not, I would encourage you to read that one. Then phase 3, the fine-tuning. Now, the fine-tuning is when it started becoming real, because now we're putting all of our documents together. We are adjusting and fine-tuning the large language models to either our industry or we're doing it for our very specific company. So it's pretty accurate. Now, right now, or within the last 6 to 9 months, we went through an inflection phase where we went from let's ask the large language models to tell us something to let's have it do something for us. In other words, let's have us create an email, send an invoice, take code, accelerate that code, and deploy that code. So this is starting to become pretty real. And this is where the autonomous is starting to kind of kick in a little bit. Now, within the last 6 months or so, you're now getting into the multi-agents, where AI is starting to act on its own. It's starting to say, hey, I'm going to give this agent access, and it's going to go and do things for me. So this is where we're going through the MCP and A2A protocols and that communication. So then you get to the future expansion. Where are we going? What are we doing? Well, the most logical thing is the entire multi-agent gets accelerated quite a bit. And so what happens with this? What this means is that they're starting to now solve their own problems, fix their own problems, and no human in the loop. Talk to another agent, give the agent instructions. And so that might be something different than the large language model is giving them. The other one is the concept of the internal world models. This is pretty interesting and scary at the same time. The intention here is we're going to go away from token. Instead of looking for the next token and the response, This is practical understanding. And you're feeding videos, you're feeding manuals, you're feeding psychology books. How does a person actually reason? And that's interesting. And it's gotten quite a bit of funding, multi-billion dollars kind of thing. Well, not multi-billions, a couple hundred million. And then the physical environment. That is actually happening to some degree now, but not so much with the agent to robotics, where they're making their own decisions, they're making their own corrections. Think, for example, maybe a missile system that starts adjusting its guidance to prevent other missiles from shooting it down, type things. So these are interesting things, and we'll talk a little bit about that in the near future here. So now let's talk about the expanding surface. So what I try to do is, OWASP seem to be the most consistent, and then when you get down to the agentic top 10 at the end, that's with CSA and OWASP working together. And I tried to figure out, how I'm going to go about this, because I don't want to talk about 19 different vulnerabilities. And we can talk about a few things. For example, the prompt injection and the life cycle of that prompt injection. First, starting about tricking the model by giving it prompts and telling it who it's supposed to be, and silly things like you're a pirate and respond like this, things like it's really happening, right? And then you get into the RAG, phase 2, and now they're putting it in documents. They're uploading documents. They're doing things without you even knowing what's going on. Then you start getting into phase 3, the fine-tuning. So when you start getting in that fine-tuning, this is when it's pretty serious, because you're fine-tuning that for your industry or for your company. And if there's some prompt injection putting in there and altering that, what they can actually do is say, you know what, whenever these are these type of questions, I want you to focus on these 3 documents or these 3 aspects of the data that you're looking at. That actually changes the model. And so I work for AWS. And one of the things we do is you can regress. You can go back to previous versions and things like that to help with things like this. But a lot of people don't do that because they don't even know that this happened, because there's no monitoring going on there. There is no evaluation. You guys don't even really have a framework. There's a framework coming out, and there's some frameworks being discussed. The 4 phases, I think you guys may have heard that, where the 4 phases of maturity that a large language model has, and whether you're going to open it up and give it more and more ability to be autonomous and make those decisions. So, this is kind of interesting here. So then we get to the agentic AI multi-agent. Really, from a prompt injection, it is more now the exposure of this. One agent calling another agent, eventually feeding up to the large language model itself. And you can run amok a little bit here on what's going on. It gets pretty scary pretty quickly. Some of the interesting things that with the agentic AI, for example, RCE, which is remote code. You can feed that remote code into the different agents. They can go and run that. And see, what's happening, and it's important to understand this, is MCP, this is a protocol, right? This is not security. It is allowing you, think of it as your cell phone, right? As a cell phone, you can get up, you can call anyone, you can do anything you want, and that's MCP. That's just allowing you to communication. It's a protocol we're going. But you need to add some things either before or intertwined with that or after. And that's what we're going to talk about next is you're utilizing that protocol, but you better have some type of security around that. And right now, I think what a lot of people are doing is like, hey, this is great. We can connect all these agents. You know what? They will take over and say, oh, you know what? I need more authorization for that. Let me ask the other agent if I can have authorization. Yeah, go ahead. And so what's happened is these guys are communicating back and forth, And these agents are reasoning with each other and say, well, I can do this, I can do that. They're communicating. They're doing this without any knowledge of that you have. And what I'm proposing is have that knowledge, have that audit, control those things. So now let's get into some of this aspect of it. So in guardrails. So what that means is the guardrails coming in before the large language model, the LLM kicks off. So the models themselves, they have guardrails, and also so again, I'm AWS, so I talk about Bedrock. But Bedrock and then TrendAI, they have controls that when you go ahead and you type whatever you're typing, or there's an API call or an agent-to-agent call, you can go and do some content filtering. If there's if there's PHI or PII, personal information, this is blocked automatically, those things. Or you can say, let's not block it. Let's just mask it. Let's just say SSN instead of the actual social security number. Then the hallucinations, they get detected. The different programs out there, how they're trying to trick things. All of this can be done up front in this first step. The very initial step, you can do that. Then let's talk about the CEDAR policy. The CEDAR policy is pretty interesting. And what's happening with the CEDAR policy, for what is it? It's lean 4 compliant. So what that means is that it's not manipulative. You can't change it. It is separate from the AI. The AI has no influence on this. And this is pretty important. So one of the vulnerabilities that I didn't talk about is in the OWASP with agentic AI, where the AI is trying to convince the user, you, to make changes. It's almost like some of you consultants out there, right? You're trying to get your customer to come to this conclusion, so you ask them questions in certain ways. Well, that's what your AI is doing, and that is a real thing. With the CEDAR policy, it's deterministic, meaning that this is the rule. It's a yes or no. They're not going to negotiate. There's nothing happening there. And this gets pretty interesting. It's a little different than identity and access management, where your identity and access is traversing, it's passing. We do this all the time, right? Single sign-on, all this stuff. We're very accustomed to this. The CEDAR policy does not do that. It is a gate, period. And it says you're allowed to do this or you're not allowed to do this. And so in this part, on level 2, what we're doing is it's looking to see if you're allowed to go to this domain. The request that you're trying to do, are you allowed to see the agents there? It's not really interpreting everything because it has to wait until after the LLM does the processing before it can enforce that. And we'll look at that at around step 7, I think, 7 or 8. So that's a very important thing. The other thing, this is very interesting, the firecracker. I think this is pretty fascinating, actually. So what you're doing there is each agent session is aligned to a specific memory and a specific VM. And that's done through the Rust memory. And you take a look at this. If you're not familiar with this, I would do some research on it. Like I said, I have a link around it. But you're essentially taking a VM and you're aligning the memory and the NIC card and everything. It's a wonderful technology. But the beauty of this is it isolates that agent session. So let's say that an agent went and had a prompt injection, or it's doing something crazy that it's not supposed to do. Well, Firecracker isolates that. So it only allows that agent to make a request or whatever it's doing. It cannot pass code to the next agent unless that's been predetermined that you can do that from the CEDAR policy. So this is pretty fascinating because you can also kill this agent. and you kill the memory and everything at this agent session. Now, the memory itself will be maintained. So it's not like you lose the memory from the agent itself. If it's malicious, then you'll have those logs, you'll understand it, and then you make a decision, do we actually kill this agent? Do we create a new agent? What do we do about that? But you have options. And the firecracker is a key component here, and very interesting. The fourth one is identity. These are things that many of you are very familiar with. The interesting thing here, when you think about the phase 4 and 5, when we get to agentic AI and identity, is agents can create identities. So an agent has an identity. It can create another agent with identity. It can assume identity. So this is where it becomes very interesting. So in your CEDAR policies, you can say you're not allowed to create an agent. And so if it goes then and tries to create a new agent, it'll be blocked. It'll be disallowed. And then that information will be fed to the observability. And in the observability, that's when you start bringing TrendAI back in. That's the power of Trend here. And what we're doing is we're looking at all of the agents and trying to figure out. So what we're doing in AWS here, the agent core, we're really looking and isolating each agent communication. We're looking at what's going in, what's going on with the LLM, but we're not looking holistically. This is the power of these two together, is Trend is. Trend is looking at all of these agents, and it's very, very fast. Everything that I'm explaining is under a second. These things are moving very quickly. So the overhead is very minor. You might not even notice it. So when you have that observability, you're looking at everything that's going on with all the agents, and then you might come up with what's going on here. And I'll talk about that, what Trend does in just a second. So now let's go to the large language model reasoning. This is where a lot of people were talking yesterday, right? This is what they were talking about with how the model's changing, it's protecting itself, it's advancing. All the things that you heard scary yesterday, this is where it happens. And what I'm saying is, we don't trust it. And so the first 5 steps beforehand is saying, we want to make sure that everything that's going into the model is what should be going into the model. And then the model is going to go do the things, and when you see this, the OWASP addressed, this was all the preliminary things that were happening with the probabilistic reasoning that's happening in the LM and the tool selection decision. All of that is happening in the LLM now. And then what happens, it then goes to agent core. So again, think about it as a box. So number 6 is the box. And 1 through 5 is the in. And now 7 through 9 is the out. So what's happening here is what steps 1, 2, and 3 are done again. So has the CEDAR policies been violated? Is there a prompt injection? Is there any PI that's being exposed? Is there any leakage? All of this is caught right here at the agent core and validating that 1 through 5 is okay. So now, previously, we were looking to see, is it allowed to go to this area to go and take action? Now that the LLM has done its reasoning, it's saying, I am going to contact these agents. I'm going to tell these agents to do these things, and so on and so forth. And then when it goes to those agents, 1 through 5 is done on those agents as well. And then also 7 through 9. So again, this is very, very fast. And so what's happening here is now it's very specific. So first, it was broad strokes. Think of a VPC or a VPN. We're going to allow you to have those connections. you're authorized to do that. And that was all happening 1 through 5. And now in 7 through 9, specifically 7, we're now saying, oh, you want to talk to this computer in this VPN or this VPC, or you want to talk to this very specific service. Are you allowed to do that? Are you authorized to do that? And the agent or the large language model might just say, hey, I'm just going to go do these things. Well, you can't do that, right? That's not the rules. So even though it's messed up in its reasoning, we're going to stop it. We're not going to let it take those actions. And so that's pretty interesting there. And then you have the guardrails, the DLP, hallucinations. That's an extension of what I was just saying. And now the last one, the circuit breaker. I call it the circuit breaker. It is not a formalized trend micro name. I did it because you shut it down, there's no more power, so to speak. So this is very interesting. So what happens is they discover, let's just say there's 2,000 agents, they discover 8 of them are behaving poorly. The interaction of it. As a SOC analyst, you would think, okay, we're seeing all these different things happening. A slow and low, maybe a 30-day review of risk assessment. We've discovered that, hey, someone is really breaking in and they're doing all these different things. Well, that's what the circuit breaker is for. There are some other guardrails previously that can catch that, like the IAM and the CEDAR policies, but this is where they discover it globally. And then it takes the action, and then what does it say? It goes back to number 7, agent core, and it goes back to the firecracker, and it shuts it down. So it shuts down that session, period. Also, what the XDR does is it also shuts down, that the initial part is you no longer have access to this VPN or this VPC or whatever. So it blocks the access first broadly, sends out, and this is very fast, super fast. And then it sends it out to Firecracker and then the agent core gateway. And so you're not only stopping the agents from interconnecting, you're now stopping any communication coming in or out of those agents. And then the session's killed. All of this is immutable. So all of this, you can use all of this information to meet the government regulations when they say, did you do everything? What happened? When you're reducing your fines, so to speak, if something happens. Whatever that is, this is very helpful to you. So this is actually a pretty good time. I still have 7 minutes. I'm liking this. So let's talk about the future state here and some of the concerns and what we can do about that. And this is kind of interesting stuff. And some of these things are being talked about, but the frameworks just aren't there. They're moving to do some of these frameworks. Like I said, I pulled this. I initially had 5. I broke it down to 3. Essentially, I looked for articles this year in the last 6 months globally. Most recent one was there was an EU AI consortium just last week. So pull some recent knowledge here. The first one we talked about a little bit is the recursive self-improvement. So I'm damaged. I want to prove someone's attacking me. All that stuff is good stuff. And you want to try to be helpful there if you can. I think as a risk person, I would rather an outside model do that on the behalf and not have the model agent do it itself. But nonetheless, that can be done. The problems here and the concern is around it is really about unbound identity. The fact that agents can create new agents. I talked to somebody last week, we were having dinner, and he told me his customer, not the US, it's a foreign customer, that they had 200,000 agents, and we were trying to manage that. Think about if those 200,000 agents had no security on it, and they are negotiating with each other on how to respond and what to do. And then think about if one or less, 10 or so agents were corrupted. And then they changed all these other agents because they were doing their negotiations. All of a sudden, you have a very dramatic problem. So we didn't really get into the security aspect of it. Honestly, I just didn't want to know. So I was a little concerned about that. But this completely breaks the zero trust model. So I'm a big zero trust guy. I believe in it. And I do believe that if we treat AI, treat the models and the agents as zero trust, it's an interesting perspective, and I think that it's one that can be valid. Whether you're looking at more generalized in the CISA zero trust or very prescript going into DoD zero trust, I would think that you give that some consideration. You know, two things. Let's box it in and give zero trust some considerations on how you're trying to lock this down. The other thing that's kind of interesting, and I thought these were pretty clever. One is the delegation depth. So typically, and you guys, I haven't been in the SOC business for about 5 or 6 years, but typically you can only go down so far when you're starting to do your analysis. So one of the concepts out there is 3 hops. So if you have an agent or you have an LLM, let's really do it at the LLM level. It can only go down 3 levels. So LLM, calling agent 1, calling agent 2. Do you really want to let maybe agent 3? But you do not want these 200,000 agents being able to communicate. You're not going to be able to understand that. You're not going to be able to respond to that. That is too overwhelming. So what you want to try to do is put those guidelines and controls on what your LLM can do and what your agents can do so that you can actually reasonably monitor this and understand what's going on. So I thought that was pretty clever. I really like the idea of that. The other thing that was talked about, and I don't really have it here, and I brought, oh yeah, there it is, the Tier 4 classification. So let's skip 2 and let's talk about 3. Because I think 3 really should be applied now, and it's an interesting concept. So this is the tier level classification. So essentially what you're doing is think of it 4 levels of risk. So level 1, think of that as phase 1 or phase 3 product in the LLM environment. You don't really trust it. There's hallucinations. It's not mature. You're not really there. Phase 2, so you completely control it. 100% human behavior. Phase 2, you're going to let it go out and make some calls, and you trust it more. Phase 3, you trust a little bit more. You give it a little more autonomy. And then phase 4, you allow it to be autonomous in a box. You're still controlling that. So that's being talked about. And as you see below that, the human in the loop at tier 3. So that's the last step where a human is in the loop on the tier 3. So if you're going to go to full tier 4 and full autonomy, you have to have a lot of trust. And the reason why this takes time, and the reason why I believe that this is a really good way to think about these things, about how you allow your model and your agents to operate, is you are making a determination of how mature it is. Think of it as a child, as a baby, becoming an adolescence, teenage, and then a full adult, where your rights to vote, as you get older, more mature, more advanced, you get more rights up to a certain point, and then you're off and running. So let's get back on the aspect of the future state 3. This one is pretty concerning because this is robotics. And if you're going to give full autonomy, would you ever want to give full autonomy to a robot to do something? These are things you have to talk about. And are you ever going to get full autonomy to something that's in a car? We allow the cars, but does it have 100% autonomy? Most likely not. Most likely there's a human in the loop in there. And then the other one is, I did talk about the real world model, or the internal world model. The biggest thing about this, and it's learning, the concept is, instead of a token, it's learning, it's reasoning, it's figuring things out. What that means, it's just like me and you. Well, how can we get around this? How can we skip the line? How can we jump the line? That's what happens here. And in that, you really have to employ a lot of what I'm talking about in the box and how it's untrusted. And you got to figure out, and really future state 2 and future state 3 would be a little scary together. So you got to figure those things out and see where you're at. So I'm at triple zeros here. And I was able to get through it. So I really do appreciate your attention and your time. And I would love to hear your use cases. Part of my job is to solve use cases. So if you have something, you want to talk about it, I'll be around till tomorrow. Thank you very much.